Hi friends, in this video we learn about double spotting in superheterodyne receiver. Before going through this video, I kindly request you to refer my video on superheterodyne receiver, which is also uploaded in one concept, one problem section. So that will be a prerequisite to understand this topic. So first we see what is double spotting in superheterodyne receiver. Double spotting is a condition where the same desired signal is detected at two nearby points on the receiver signal, right? So what is this? Let us see. So here the receiver dial, that is our radio receiver dial, will detect the same desired signal at two points. That phenomena is known as double spotting. So what should be the reason for this double spotting is it is due to inadequate what you call image frequency rejection. So I have explained what is image frequency and all in super heterodyne area video. So please refer that. So the reason for double spotting is inadequate image frequency rejection. Fine. Okay. So here you see we receive, we detect the same signal at 2 points, right? So that one point is known as desired point. One must be the desired point. Another point is the image point, right? So another point is image point or spurious point. Okay, right? So we detect same signal at 2 points, right? The name for 2 points I have given here, right? Okay, then what is the main purpose of double spotting? Sometimes it is double spotting DS is used to determine the intermediate frequency of the unknown receiver, right? Used to determine the intermediate frequency of an unknown receiver. That is the main thing we have to know about double spotting phenomena, right? Okay, so I told inadequate image frequency rejection, or the other name is poor front end selectivity. The other name is poor front end selectivity. These are all the, this is the reason for double spotting in super heterodyne receiver, right? Okay, so why don't we need this? Why don't we need double spotting? What is the problem with double spotting? Right? So the main problem is because what will happen is if double spotting occurs in receiver, here what will happen is the strong signal might mask and overcome the weak signal. Might mask and overcome the weak signal at spurious point or image point, right? So at a spurious point, right, in the image spectrum, frequency spectrum, right? So that is the main problem. So weak signal will be suppressed, only strong signal will be received, right? So that is the main problem with the double spotting. Even though our required signal is weak signal, this will be suppressed by the strong signal, right? So this is the main thing we have to know. Okay, fine. So now another important thing we should know about this spurious point is this spurious point lies precisely to Fi, right? So to FIF, right? So to FIF below the correct frequency. To FIF below the correct frequency. That is 2 times the intermediate frequency below the correct frequency. Let me explain everything in the problem, right? Let us see that. So let us take one problem. Okay, what is the condition is, let us assume that we have a strong signal, right? So assume the problem is we have a strong signal at strong signal, right? Fs. Fs at 1640 kilohertz, right? Also assume intermediate frequency FIF is 470 kilohertz. Fine. Okay. So if the signal station frequency is 1640 kilohertz and intermediate frequency is 470 kilohertz, means what should be the local oscillator frequency? This we have studied in super heterodyne receiver video. Please refer that. That is given by Fs plus FIF, that is 2110 kilohertz. Right? It is for I-side tuning. Okay. Suppose for the same 1640, right? Same Fs is trunk station is 1064 kilohertz. Suppose if I tuned my local oscillator to what you call 1170 also, what should be my FIF I get? FIF. Here you see Fs is greater than FLO. That is, incoming frequency is greater than FLO, means FIF is nothing but the difference between Fs and minus FLO. This we have studied in super heterodyne receiver. So this will also produce the same, what you call 1140, right? Sorry, 117. So same 470 kilohertz. So for same, to produce same intermediate frequency, here also 470 kilohertz, here also same 470 kilohertz. What will happen is, here if I tune the local oscillator to low side or 1170 kilohertz, I will tune to the same 470 kilohertz, right? Actually here I have used I-side tuning. If I used I-side tuning with the FLO, if I use I-side tuning with the FLO is 1070 kilohertz and the FIF is 470 kilohertz, means what should be the original signal I should have got? Fs should have been FLO minus FIF, right? That should be 700 kilohertz. But what happens here? This 700 is weak compared to the strong signal 1640. So this weak signal is masked and overcome by 1640. This is called double spotting. Right? So I hope you understand what is double spotting now. Actually, originally, let us assume I should have tuned my local oscillator to I-side tuning. If I tuned my local oscillator to I-side tuning, means it happens like this. Suppose if 1640 is a frequency and if I have a local oscillator frequency of 1170, what happens? My intermediate frequency is still 470, right? But actually for 1170 for I-side tuning, what should be the signal frequency I expected? I expected signal frequency of 700 kilohertz, but what I received is 1640, because this 1640 dominates this 700. So compared to 1640, this 700 is weak and it will create double spotting. Moreover, what is the last point I told? Where should be the spurious point? Spurious point lies exactly 2 FIF below the correct frequency. What is the correct frequency? The strong frequency, that is 1640, right? 2 FIF below, that means left hand side, the difference should be 2 FIF. So 2 into 470, right? So 2 into 470 means 940. 940 below, that means it should be 700. So this is what's spurious. So what happens here? Here you see 2 points where station is tuned. So if these two are the same points, 2 points at which the station is tuned. 1640, 700, right? So this is called double spotting. Okay, so who is a dominant? This 1640 is a strong frequency, that is weak frequency is 700 kilohertz, right? So double spotting occurs at 700 and 1640, right? The difference between the original point and the spurious point is 2FIF, right? This difference is 2FIF. I hope you understand this concept. If you have any doubt, please ask me in comment section. I will clarify. Thank you.